In this experiment, you will learn the basics of the function and operation of an oscilloscope and a multimeter. This will be used to study the charging and discharging curve of a capacitor and the behavior of a coil. RC circuits are combinations of resistors and capacitors and show a characteristic exponential decay behavior. A cell membrane, for example, with low conductivity as a boundary layer between conducting electrolytic liquids, can be described as an electrical parallel connection of a resistor and a capacitor. An oscilloscope is used to continuously record fast electrical processes as a function of time, e.g., alternating voltages or current voltage pulses. It displays voltages directly as a function of time and hence enables the observation of fast processes with high frequency. In the first part of the experiment, you should become familiar with the oscilloscope. Connect the input of the oscilloscope to the power supply unit and display a sinusoidal alternating voltage on the screen of the oscilloscope. Then observe the screen with different settings of the oscilloscope, e.g., varying the time resolution, the trigger level, the polarity of the trigger slope in the trigger menu, or the measuring range of the voltage. Now measure the values of the resistors RC and RL in the alternating voltage test box. To do this, connect the outputs of the multimeter with the connection sockets above and below the RC or RL resistor. Do not apply external voltage. This distorts the measurement and can damage the multimeter. Connect the power supply unit to the input of the frequency generator. Make sure that the output voltage of the power supply has an amplitude of 24 volts. Connect the oscilloscope to the output of the frequency generator. The output voltage of the frequency generator is displayed on the screen. Measure the maximum amplitude as well as the oscillation period and the frequency of the output signal. Now we study the charging and discharging of a capacitor via a resistor. Connect the variable resistor to the capacitor via the jumper conductor. Now measure the voltage drop at the capacitor with the second channel of the oscilloscope. To do this, switch on the second channel. Select the same range for both inputs of the oscilloscope and align the zero lines of the two inputs in the lower part of the picture. Please note that you only need one ground cable for this. Change the variable resistor and observe the change of the charging and discharging curve of the capacitor. Take 2 or 3 screenshots of the oscilloscope which show the changes. Now we measure the capacitance of a capacitor with the oscilloscope. Connect the fixed resistor to the capacitor. Show the charging curve of the capacitor with best possible time resolution on the screen and measure the voltage at the capacitor as a function of time. Save again a corresponding picture for evaluation at home. Also take a picture of the discharge of the capacitor. To do this, change the trigger slope in the trigger menu. Finally, we take a short look at the high-pass characteristic of an RL circuit consisting of a resistor and a coil. Remove the jumper conductor between RC and the capacitor and connect RL to the coil instead. Now look at the behavior of the voltage across the coil and save a picture of it. In the analysis, explain the dependence of the charging and discharging of the capacitor on the resistor and determine the capacitance of the capacitor. It should be made clear why an RL circuit is also called high-pass.